Hello. I just got back from conferences in Europe. I went to the Front conference as a speaker, talking about what I'm going to talk about today. And I went to the Svelte Summit in Stockholm, which I met amazing people. Although I didn't get my chance to speak at the conference, but the speakers lineup are so amazing. I learned so much in the conference itself, and I met a lot of friendly people. Met to meet some of you people over there. So hi, hello. Anyway, today I'm gonna talk about what I talked in the Front conference at Zurich. So it is recorded, but the video will be released probably until next year, where they are starting to sell tickets for next year. So people who bought the tickets this year still get to watch the videos recorded on live. And I talked to the organizers. They are okay with me for give this talk again in different places, even on my own YouTube. So I decided that I really want to share this to all of you. So I decided to re-record it again, probably in a studio environment. We have my nice friendly pals behind me watching my back. Hopefully I give a better talk this time. So without further ado, let's jump right in. So hello people from the YouTube. I have my screen over here and I have some notes, so I will constantly look down. But how are you? So my name is Li Hao, as you guys know, and most important thing is that I have a YouTube channel. But before that, I'm from Penang, in a lovely town called Bukit Mertajam. Some of you may have not even seen the picture of Bukit Mertajam. This is how it looks like. So Bukit stands for a mountain, a little small hill. Mertajam, it's like a pointy hill. So we live under this mountain. You have nice people, nice cars, and nice food. And most importantly, I have a YouTube channel that I talk about programming stuff, such as Svelte, or over here we have Webpacks and build tools. So I try to do content about front end that I basically wish it was there when I first started out. Things like this. Right. So when I first started out, doing a bit of front end, when I started building web applications 8-9 years ago, I started with jQuery. jQuery provides me utilities to select some elements and do something with them. And when the users interact with a page or when the data changes, I use jQuery to find elements and modify them directly. But this gets messy quickly when your applications get complex. So fast forward a few more years as I started using React, which allows me to describe my view as a function of the data. This declarative approach frees my mind to think about how to modify the elements, but lets the React library to figure that out. The way how this works is that React takes the different snapshot of the virtual DOM, comparing it, and figuring out the actions needed to update the actual DOM. This comes with a cost, and because React has no idea what type of virtual DOM there will be, whether it's this element, that element, this event handler or that event handler, so it has to have code to prepare for all eventuality. So for simple applications, the React library code may be overweight relative to the code you write. This, of course, is a trade-off. Your code is no longer as efficient as you would have it, like in jQuery, but you gain the ability to describe a much more complex UI. So maybe in a more complex UI, the weight of this React library may not be as much as you would think. But what if you can write your component declaratively, like how you would do in React, but you have a tool to turn it into optimized JavaScript code, like how you would write in jQuery? Well, that's when I started to learn about Svelte. So for those who don't know about Svelte, this is how a Svelte code looks like. the Svelte syntax resemblance of the HTML syntax. You can define variables in the script tag and use it in HTML using the curly brackets. You can define CSS in the style tag, and here you see the style. To make changes of the variables, you can modify them directly as how you would modifying a variable in JavaScript. So here, when I click on the event listeners, I add a on-click on the event on the element. So when I click on it, it will call the decrement function, which will then modify the counter by doing the counter minus minus. It's that simple. So how does that work? One explanation I hear a lot is that Svelte is a compiler-based framework. It takes your code you write, analyze it, build, compile it into JavaScript. So you can do a lot of magical stuff that you can't do in JavaScript. But still, how does it work? I'm a big fan of the idea of getting your hands dirty. And I personally have learned a lot from resources like this, how to build your own jQuery, how to build your own React. So today, how do you build your own Svelte? I haven't found a lot of content or any content at all about how to do that. So today we're going to figure that out together. I do realize that this maybe is your first time. I mean, I guess I have this in the script where some of you are really your first time learn about Svelte. And you are in the right place because you are watching my YouTube video. And you can go down and take a look, click on my channel, because I do a lot of YouTube contents about Svelte. So if you want to learn about Svelte, watch them and subscribe to my channel. So today, instead of talking about how to use Svelte, I'm going to talk about how to create Svelte, how to create a compiler-based framework like Svelte, or like Quick or Meta or Mako or a lot of other things, right? So I'm going to talk about how to create a compiler. And first of all, a little confession. I have a computer engineering degree, so I may have a little bias, but I did not take any compiler modules during my degree. So the word compiler sounds very scary to me as well. So don't worry, I'm here for you. So this is what we talk about compiler, right? In general, this is a breakdown of what a compiler do. It takes your code, parse it, analyze it, and finally generate an output. Let's take a closer look at each stage. When we say the compiler parse your code, it takes your code, generate a representation of a code into a tree structure, right? Which we call this a abstract syntax tree, or AST for short. What it is called abstract is because it contains abstract structure of your code, as opposed to a concrete syntax tree where it has all the concrete information such as where is the semicolon, the parenthesis. In abstract syntax tree, those are irrelevant. And then the compiler will analyze your code. What this means is that it will recursively go into every node in your tree, gather information such as what are the variables declared, which variables will change, and so forth. Right, so armed with those information, the compiler is then going to generate a more optimized code. So today, with the time permits, we are going to implement a very, very simple version of Svelte. And this will be the component that we are going to compile. And the Svelte feature that you did not find in this component will not be implemented. This is the example counter component that we just saw. Right? So let's take a look at my project setup. So over here, I've prepared my code. First thing is you take a look at package.json. I've installed a few dependencies, but don't worry, we'll talk about them later. And here is my component that I just showed you, right? And index.html is where we are going to preview our results later on. So here we will compile app.svelte into app.js, and then in this HTML, we are going to import this app.js and use it, right? Don't worry about this, we'll talk about it later. So in the index.js, I've took the liberty to start with a boilerplate. I've read the file using file system from the Node module, from the Node API, and I'm gonna parse it, analyze, and generate the code. And so these three functions is what we are going to complete later on. So keep mentioning that Svelte Compiler will compile this into an optimized JavaScript, right? But how does that optimized JavaScript look like? I mean, since we are creating a simplified version of Svelte, how about let's just redesign the simplified version of the output? I know some of you have heard or read or watched my videos about compile Svelte in your head, but this is our compile minified Svelte in our head. We're gonna design a much more simple output because we don't need a lot of features over here. So the simplest code for creating a button would probably be like this, where you use DOM API such as the create elements, add event listeners, append child. We need a function to create and destroy the buttons separately. So I'm going to wrap both of them with an object method into an object called a life cycle. And we want to be able to create multiple counter components, basically multiple instances of the life cycle, the create and destroy methods. So let's have it as a function that returns this. So here I can call the app function, which to create a new component, right? So it returns me a life cycle, and then I can call .create to create a new component element inside the body. Oops, I think I forgot that the button does not have a text yet. So let's add a few more lines to do that. So we use the create text node and append to the body, to the button. So if we keep doing this, keep adding codes to build up the components. And wait, hold on. Counter expression here, as we can see from the code, is dynamic. So we need something. We need us add a lifecycle method called update to update the counter text node. And we can try to call the update method up right after we modify the counter, something like this, right? But how do we know in the first place that counter variable is dynamic? Well, that's why you need to analyze the code. That's why that step is important. And you may ask me, the way I visualize the code on the screen, from the left to the right, you can see I'm hovering on different parts of the code. It seems straightforward visually, but how do you implement it? Because at the end of the day, this is just a blob of strings, right? These are characters. How do you understand these strings? How do you know what are the elements are there? Well, that's why we need to parse our code into AST. It will be much clearer if you visualize it together with the AST. Because going through elements one by one would be simply going through each nodes in the AST. So that's why AST is important. So now we are begging the question, how do you parse a string into an AST? Like all things in programming, there's always a technique to do it. And today I'm going to show you how you can do that. So first of all, we need to describe how our code will look like. And to describe it, we need something called a syntax notation. So writing a syntax notation is like writing a design document, but this is for describing how your syntax would look like. We need this before we can even start writing our parser. There are various syntax notation, such as the railroad diagram or the Backus-Naur form. In this example that I show you, this Backus-Naur form syntax notation describes how a JSON object syntax should look like. I believe most of us know how to write a JSON object, right? So a JSON object itself can be either an open and close, literally open and close brackets, which means empty object, or it could be a open brackets, a list of properties, and a closing brackets. So here, how does a property list looks like? Well, a property list could be one property, or a property list with a comma, literally, and then a property. And there you have property, which can be a string, JSON string, colon, and a JSON value. And can keep defining on how an object look like. Here you can see that this definition itself can be recursive and can depends on other syntaxes, other definitions. Well, you get the idea, right? But today we're not here to talk about the syntax of JSON object. We're here to describe how the Svelte syntax should look like. So I'm going to call the Svelte syntax as HTML fragments. And in the syntax of fragments, it's just one fragment or multiple fragments separated by white spaces. And the fragment can be either a script, elements, expressions, or text. So for a script, it will be something with literally a script opening tag, some JavaScript, and a script closing tag. For elements, it could be a angle bracket, tag name, list of attributes, close brackets, and then fragments, and then list of any of the above more elements, which is expressions, tags, and then you have the angle brackets slash, and then tag name, and then angle brackets, right? I mean, it's a bit lengthy, but basically you go ahead and write out, define one by one what is this each type, what is their syntax should look like, right? For example, in these expressions, in Svelte, it will be a curly brackets, some JavaScript, and curly brackets. So with that, let's take a look at how we can implement, right? So here we define multiple types of definition. And so what I'm going to do is I'm going to write code, a function for each type, right? And I'm going to speed typing over here because it will take a while to type. So I'm going to type really, really fast. Okay, something like this. So here you can see that I have functions for each type of the nodes. So now let's get back to our thing, right? So you probably noticed that there's an I variable over here. What does that do? Well, this I variable is actually like a pointer. It points to the string, and so looking at I, you know that what characters you are looking at. And the core idea of a parser is to match the characters where I is currently pointing at, so you know what you are parsing for, and then advance I based on the syntax rule that we just defined earlier on. Something like this. Okay. So with that, we're gonna write 3 helper functions for us to match what the characters I is pointing at, to advance I, and also to read value what I is pointing at. So let's do that. So the first function is called match. Over here, let me close this and let me zoom in a bit. So here we are going to slice out the characters and compare whether it matches, right? So this returns a Boolean value. If it's true, it matches. If it's false, it's not matching. The next one is the I'm gonna call it the it function. So in this utility, it's like when you, for example, when we are parsing an attribute, after you parse an attribute name, over here, take a look, you know that we are immediately needs to match, and we need to match an equal and curly bracket sign, right? And these 2 characters, once we match it, we don't really need it, but we need to match it, right? So this is what it does. It will try to match and advanced I by it, and if it does not encounter, just correct. If it's not encountering a equal and a curly brackets, then it will throw error such as like syntax error, right? So this is what it does. I call it parse error, and I'm expecting these certain characters, right? The last util function is to advance and to read the value out where I is looking at. So we're going to call read while matching. Here I'm going to use a regular expression. So I can keep reading as long as I match the characters I is looking at is matching. And then after I read and reach a character that does not match, then I will return all the value that I have read so far. So with these 3 functions, now we are armed. We're going to start with the fragments, right? So here, first thing is you see that fragments is either a fragment or multiple fragments. So here, let's try to do that. Fragments, we make it an array, and we're gonna keep calling parse fragments, right? So anytime when I encounter something right? The key idea of having all this as a function is that we can call and delegate this function to do that for us. Right, so for fragments, as you can see by the definition, we say pass script elements, expressions, and tags. Right, so that's what we're gonna do. Script, element, expression, and tags. So for script, now for script, here we know we need to match some. If it's matching the script opening tag, then it's a script. And with that, we will eat some JavaScript tag, and then we'll parse JavaScript, and then we'll eat a closing script tag, right? Something like that. So let's do that. If it matches, we're gonna eat it, and we are gonna take out the content. And over here, the code that we take out is JavaScript, and we need something to help us to parse JavaScript. And that tool is called Acorn. So let me import Acorn. Acorn parse. And then finally, after we parse it, we have to eat away the script tag. So the next thing that we need to parse is the elements, right? So elements, see, we will try to match the angle brackets. If we can find that, we're gonna eat it, and we're gonna keep read away the tag name, and then we're gonna call parse attribute list to parse attribute list. I'm gonna eat this character, and then I'm gonna call parse fragments, and then eat the angle bracket slash, and then I think by the time we know what's the tag name, so we can also eat this as well as eat the angle brackets, right? So with this definition, it's much easier to know what we need to do, right? So let's write that out. If we match it, we're gonna eat, and then we're gonna read the tag name, as I said, and then we're gonna parse attribute list. I'm gonna eat this, and yeah, basically that's it, right? So for children, we're gonna call the parse fragments to read the fragments, but I mean the fragments that we had is keep reading until the end of the contents, but maybe we can make this as part of the parameter as a condition, right? And then here we can pass in a different condition. Basically, we keep reading until we hit the end tag. So end tag would be something like this, right? And then we're gonna eat away the end tag and return the elements. So far so good, right? So for attribute list, similarly, if you look at over here, you see that you can either some white spaces and parse attributes, and then keep parsing attributes. So here we're gonna do that as well. White spaces, right? So we skip white spaces. We don't have this function yet, so let's write it. So this is basically similar to read while matching, like because here you have regular expressions, so you keep reading white spaces, but you just discard whatever you just read out because they are just white spaces. Then while matching the closing script angle brackets, we keep parse attributes, right? And then for attributes, what we have over here, if you look at definition, is to read something until we hit the equal sign. So probably read while matching not an equal sign, and then you eat away equal brackets, and then you parse JavaScript, and then you eat away the curly brackets. So here, let's do that. Right, we parse it, and then that's it. So for expressions, here you see that if you're matching these curly brackets, you're gonna eat this, parse JavaScript, and eat curly brackets. So for tags, basically, in the definition, text is just anything else, right? It's not script, element, and expression. So we just keep reading any characters that is not a angle brackets or not the curly brackets. So this is what we're gonna read while matching. And to make things simple, we are not going to have text node that is just plain white spaces, right? If you look at the code over here, we probably can find like maybe here and here in between you have white spaces, here and here you have white spaces. If we encounter those, we just ignore the text because we don't want to create too many nodes so that our output looks simpler, right? So we check if it's just white spaces and we just discard, right? We only create a node if it's plain white space, not white spaces. For parse JavaScript, again, we can use Acon to help us. Have this function called parse expressions. We will parse JavaScript expressions at the location. And then of course, we are going to advance our I, because after we parse, we're going to advance our I, right? And I guess that's it, right? If you look over here, we basically finish everything. Let's try run our code. Here we have our AST, and maybe I'm going to write our AST into a JSON file. Something like this. Let's see. I'm going to just write it over here. So I'm going to run my code. Node index.js. Oops, sorry. JS. And here you can see this is our JSON, the tree structure, the AST that we have. Oops. I think I should write it in a JSON file so that it can format it nicely for me. Oops, sorry, something like this. Over here instead. Let's try and run this. Now I have a JSON file. You can take a look at the tree structure. Right here, I have my script and I have my HTML. Right, I have a button element over here, and then there's an attribute called onClick, and then the value is in identifier, which is like a JavaScript AST. And we have a children, which is a text node, which has a value called decrement. Right, the next thing is you have an expression which has the counter, and then we have our second button, which is an element, and the attribute is the onClick, where the value is increment, right? And then you have text node inside. So this is the tree structure that we have. It's just a JSON object, right? You can step through here, like go in one level and then go to the children of the body, go to the children, go to the attribute, something like that. That is like traversing your AST, right? So at this point, we have our AST, right? Next thing we need to do is to do our analysis. So what are we going to analyze over here? Well, look at this code you have. What are we going to analyze, right? We're going to know what are the variables that's available. So here you can see this, by eyes, we can tell is this variables. And what other variables will be changed, that can change, that will change? Well, from what we see, it's these variables, right? So you may think that this figuring out what has changed is easy. I mean, like you can have a map of all the of a string value, like the counter as a string, you store in a map, and then if you encounter that it is trying to modify that counter string, and then you mark that this is changed. But this is not that simple, because you need to consider something called a scope. Because if you look at the code like this, you can immediately tell that this line, this counter is not changing the variable outside, right? Because you know the scope. You know that this is referring to the counter that's defined inside, right? If you have everything like this, then probably the counter variables outside, no one's changing them, right? So by looking at this, we know there's a scope, and here I visualize it. And again, you may ask me, hey, Li Hao, how do you know? How does it, like, it's easy to visualize the scope, but how does it look like? How do you even can tell? We can tell that because we by parsing the code with the AST, and it's much easier to tell from the AST. So this is the AST for this JavaScript code that you see on the left. And if I try to color code the scope, you realize that a scope is like a subtree of the AST. And then the root node of the subtree is always a node that creates that scope. And in this case, it's usually like the block statement or like arrow function and things like that, right? So we're gonna use because of the time constraint, we're not gonna write how the code to parse or to analyze the scope. We're gonna use a library to do that, right? We're gonna use this library called Periscopic. And this Periscopic has this analyze function that returns two things, right? Three things, but two things that we are concerned about. One is what is the map, and one is the scope. The scope will be the root scope, and map will be a mapping of the nodes and the scope that the nodes creates, right? So for example, in this case, the map will have 3 entries, right? One for the root scope, one for this child scope, one for the green child scope. And the node, the key, which is the root node for each of this subtree, and the value will be the scope that it creates. Okay, so we are going to do that. So here, let's get back to our code. Okay, this is where we left off. I'm going to write our analyze function. So here we are going to maybe have a result object to store our result, right? The variables, what will change, and also what will be used in the template. This is basically similar to what will change. Okay, so here, import periscopic, do this scope analysis for me. And I mean, with this analysis, basically we can already tell, like from the root scope, we can know what are the variables that is being declared, and those are the variables that we're going to store, right? We're going to keep count of the counter, the decrement, and increments. These are the variables that is available that can be used in a template. And of course, we can store this as a root scope, and then we also can store the map as well, so just in case for us to use in the future. So now in return, we are going to return this result, right? And now we are going to do our, with this scope, we are going to figure out what variables will change. To do that, we need to traverse through the tree, and to do that, we need to basically keep track of what is the current scope. Right? We're going to use this library called ES3Walker to traverse through every node in this tree. And this ES3Walker does it in a depth first search manner, something like this. Okay, so later on, when it goes in, goes into a node like this, then we know that we enter a new scope. So we update our current scope to the new scope, right? So we know this because we look at our map, and if this node is in the map, then it knows that it creates a new scope, right? And then as we go down the tree, and then when we come back, when we reach this node again, then we know that we are exceeding this. So once we go in, we are always on this current scope. And as we go out, then we know that we are exceeding the current scope. We are going back to the parent scope. So we can update the current scope again. Right? So in this ES3 function, there's two methods. One is called the enter, and one is to leave the node. Right? So that's where we're going to update our current scope. Right, so I mean, we're just gonna type out what I just said earlier, right? Updates this current scope based on the map, and then when we leave, we update back the current scope to the parent scope. So with this, let's see. So the next thing we need to do is to figure out what variables will change, and to do that, we are going to know which statements will change our variables, right? So I use a tool called AST Explorer, and you can see over here, you pass in the code over here, and then you are able to basically hover upon each node like this, and take a look at what is the type of the nodes. Right? In this case, this one is, this whole thing, this plus and everything, it's called an update expression. So whenever we encounter an update expression, I'm going to assume the argument is always just an identifier, which is like a variable. And I'm going to mark this variable as change, right? And of course, this variable, we have to find who declared this variable as well. Okay, so if it's declared locally, not in the root scope, then I'm not gonna mark the root scope change counter as will change. Let's close this and let's return to our code. I'm gonna check if this is update expressions, and I'm gonna use a scope to find the owner of this variable name. Right? Basically, it's telling us which scope is declaring this variable. And if it's equals to the root scope, which we have over here, then we are going to mark this as will change. And I guess that's it. That's that simple, right? So if you want to handle other scenarios like assignments and stuff like that, then you have to check those nodes as well. So next thing is we're gonna do what will be used in the template, right? So here again, we're gonna traverse through the fragments, the Svelte AST that we have created earlier on. So here's a traverse function, and we're gonna call traverse on every nodes, right? So for example, when we enter a elements nodes, then we are going to go to its attributes as well as its children. Well, elements itself is nothing special, right? But if we encounter attributes, then I'm just gonna assume, based on this code over here, that all the values of the attributes are some variables that we are using, right? So here, when we go into attribute, we're gonna mark we'll use in template for that variable, right? And we'll just assume it's a normal variable to get the name of that variable is like this, right? But if it's a member expression like a.b, then you don't get the name directly. You have to figure out like what you have to traverse that a.b JavaScript AST to find the a identifier node and then .name to get the name of a, right? But I'm just gonna assume this for now. And if I encounter expression node, I do the same thing as well. And also I'm assuming that the expression node over here is just a normal variable, right? With this, I think we are done. So let's take a look at our result. So if I come over here, analysis, let's comment this too, and I'm gonna console log analysis. And let's take a look at what we have. So here, analysis, you see that variables, counter, increment, decrement. What will change is counter. What we'll use in template is this tree, right? Root scope and map, we can just ignore for now. But if we come over here to the code, let's see, let's try to break it. Let's comment these two out or remove them, right? And you try and run this code again, you realize that what we'll use in template is just increment, which means our code is working, right? If it's not used, it's not shown, it's not marked. And let's undo this and let's take a look at our scope analysis, right? I mean, before that, if we remove this variable, right, save this, then you see that variables only have counters and increments. And if I come over here and declare a variable like counter equals 0, like this, if you run this again, you realize that this is modifying this variable. So will change is an empty set. So basically, we have done a good job in doing the analysis, right? Let me revert everything that have made changes, and let's go back our code and see how we can generate the code, right? So we are going to write the generate function. Oops. So here in generate function, what we need to do is figuring out the code that we are going to generate, right? Let me pull out my slides. So what we do is we're going to go through elements by elements in the AST, and we're going to generate codes for each element. So as we stepping through, I mean, if you look at the result, we have the create, the destroy, and probably the update. So we're going to have an array for each of them, as well as the name of the variables. So we have 4 arrays to keep track a list of code that we are going to add at each point. And as we step through the node in the AST, we're going to push the code that we need into the array. So here, I'm going to have the variables array, create, update, and destroy. And let's have our template out. So our final code would look something like this. Okay, let me quickly type it out. Right, so here we pass in the create. We're going to loop through. We're going to join with a new line and put the create array content over here, update and destroy. I think we need variables as well, right? Each variables we're going to use a let statement. So with this, we're going to step through our AST, right? Before that, we also need a counter, right? This counter is just for us to name our variables, right? If you look at over here, the code, we can name like the variable name based on the type of the element, but we have 2 buttons, right? So we have to say button 1 and button 2. So counter is for that. And we're going to make it easy. The counter is always increment for each element. So so we don't have to worry. So you will be having like a counter 1, text 2, div 3, and then text 4, and then another button 5, and then a text 6, something like that. So let's go through each node one by one. The first node we will probably encounter is the elements node. So for elements, if you look at the code over here, we'll call create element to create that element, and we are going to append child to append the elements to the target, to the parent, or something like that. And for destroy, we're going to add the remove child statement. And of course, we create a variable name. We're going to push that in a variable list. For create, document create element. And then of course we need to code for attributes as well. So we're going to loop through attribute, and we're going to call the traverse, and then we're going to write that functions later on. And of course our children as well. And then we are going to add this statement called append child with the parent. So parents, we're going to pass parents later on. And so over here, when we go to traverse, again, what we have is that the parent now is this current elements that we have, the variable name that we have. Okay, and we're going to have destroy as well. And that's it for elements. So the next thing is probably the, let me see. The next thing is the text node, right? So here, instead of create element, we're going to create text node. Same thing, we just append. I think I missed out the destroy, but let's just ignore that. So we're gonna append this thing, variables, gonna append child, and that's it. And next thing we have is the event listeners, right? So we're gonna assume that if all attributes are just event listeners, I'm gonna just handle that. And event listeners, we know that it starts with on and then a colon. So after that, whatever it is the name of the event. And this one, the variable, the attribute value is gonna be the event handler. This is gonna copy paste directly in over here. So to do that, let's write our code. We're gonna start with on. I mean, we do some check, and if it does that, we only handle this case. Gonna slice away and then find our event name, and then for event handler is the variable name. So we're gonna add event listeners with events name. Here I also like add the quotes like this, so that it's because it's just a click CLICK, but it needs string quotes to wrap it around. So we have our attributes. Now next is, I think the last one is the expressions, right? We want to have and the expression itself, the statements to create the node is simpler. It's the same thing as the create text node. It's like the text node, but you also have the update statement if counter itself. If we check the analysis and we see that the counter will change, then we will have this update statement. So to do that, similar as create text nodes, we're gonna type really fast forward. Wow! Okay, so now we need to do the updates, right? So we're gonna check our analysis. So if our analysis have this variable, this variable name, then we're gonna add the update statement. Yeah, basically to say the update the text value, right? And I guess that's it. So we haven't really called this traverse from the outside yet, so we're gonna do that right now. And with this, let's try to run our code. So let's clear this and let's try to run our code. And immediately you can see here we have, let's see, all the statements, like all the variables 1, 2, 3, 4, 5, and all the statements to create the nodes, updates, destroy, right? So if I try, and if I'm in a hurry, I'm gonna try to run this. I'm gonna start our server. So here we export defaults this function, and in the HTML we are importing this file, and we call the create document body, right? So let's try and run this. Open this up. Something is not quite right. Let's take a look at the console. Okay. So you get error because the decrements, the variables in the script is not here yet, right? We don't have these variables from all this, the counter, increment, and decrement. So we're gonna add them. Don't worry, we're gonna do that. So let's get back to our code. Let's close this. Let's try and do that. So what we can do. Oh, where's my cursor? What we can do is before that we are going to copy. We're gonna add the lifecycle.update statements. So that is kind of similar to what we do when we try to figure out what has changed. Basically, find where we change the variable, like the update expressions, but we only add one more condition, which is which is like, if we'll use in template only, we're gonna do this. And what we're going to do is we're going to replace this note, right? So just ignore the code that I'm typing over here. But basically it does is that you're going to add this lifecycle updates right after, okay? And yeah, with that, now our AST script has changed a bit. And with that, we are going to add this AST script into our code, right? Something like this. And we're going to turn it into string using this library called ASCodeGen. Generate a script AST to JavaScript AST to string, and there we have it. Okay, so if I come over here and try to run this again, oh man, I think I screwed up my auto typing. Okay, so I think I just wait, hold on. Yeah, I think I just type into the app.js file, but I actually need it in the index.js file. But it's okay. I mean, we can copy some of the code, or we can, I think, which is good. We can redo that again. Now you can see my actual typing speed. One thing we did is that we added the ESCodeGen, right? ESCodeGen.generate the AST.script. Generate, I can't even type now. Generate ESCodeGen. We can import this from ESCodeGen. Oops, sorry. ESCodeGen. So right, let's run our code. So here you can see that now all these variables are here now, right? You can have it on top, you can have it after, below. It's up to you, like this. Then you have it above, right? All the code here is above, and of course you have all the variables, but it's not reactive yet, right? If I try to start our server and take a look at the result, it's not reactive yet. Okay, so what we need to do is to come over here and add the lifecycle updates right after, right? So I am going to copy the code from here, the where is it? Analyze the traverse. Yeah, this one. Copy this over here, paste it in counter. Yeah, paste it. I think we can do it after. Paste it in. As I said, we're gonna check another condition called Analysis. That will use in template that has the node.argument.name. And if so, we are going to do something, right? We are gonna this.replace with a node, which is the current node, and then the code that looks like this, right? The lifecycle.update this thing. I think it's the name of the variables like this. Lifecycle.update. Yep. And this is just a string. I can't replace it, so I'm gonna use econ to pass. This is like a cheat expression at. But I mean, in real life, we are not doing this way. But this is the simplest code that I can write. That I think is understandable. Okay, let's try and run a code and see whether it works. Whoops, hold on. Root scope is not defined. Okay. I think I didn't copy everything. So root scope comes from root scope, and the maps, the variables are going to come from the result. I'm going to use them. Okay. And no, not the result, the analysis. And here, we cannot, is this called replace? Oh man, I need some time. Let's see. I'm gonna look up to my code. So this is a good chance to tell you that all this code that you are looking at is available in my GitHub called the mini Svelte. And I'm gonna copy the code in Next.js. I think I need to make it an expression or something, right? This replaced with a sequence expressions. Oops. Over here, I'm gonna do this. Close this. Okay, hopefully this time I'm gonna get it right. Okay, no errors. It's a good thing. Now we have replaced it, and we have this counter and a lifecycle update. And so now, moment of truth, if I try to start our server and try to take a look at the results, refresh, you see that decrements goes down and the increments goes up. Wow, you've done it. I'm not sure how much time we've spent over here, but it's definitely less than an hour. And the code that you write is, let's see, it's less than 300 lines of code. You get a Svelte compiler. And this generates optimized JavaScript code as we promised. Because let's take a look over here. All right, this is on the right. This is a code that we have. This is a code that it generates. Okay, and we always say that the analysis step is important because it analyzes the code and tries to generate it as optimized as possible. Right? So for example, if you're not using counter at all, like this, you remove it. Then if you try to run the codes, you realize that, of course, I mean, you don't have update statements, that's a given. But if you look at the code over here, we don't inject that lifecycle.update methods, because we know that counter, yes, you change it, but it's you don't have to call the lifecycle update because it does not trigger something, right? And same thing goes if I remove these two lines. Instead, I don't change the counter, right? And I try to run again, or like if I change the scope or whatever, right? And immediately, if you look at the code, you'll realize that my update here is empty as well, because I don't need, the counter variable will never change, and I don't need the update statement. Of course, you can tell me that why you did this, right? So of course I can add more conditions, like say if code.update.length is 0, then or like more than 0, then we can add this part in, right? Something like that. I mean, I can't write if, I have to do it this way, and then like empty. Okay, I think I need this over here, right? Yeah, I could write something like this, and now it's even more optimized, right? You don't have the update method over here. How good is that? So this is definitely a very, very simplified version of Svelte. And let me do some summary, right? Summary, what we've learned so far, we've learned how to write a compiler. We go through the parsing step, the analyze, and finally we generate an output code, right? And of course, I can't answer your questions over here. You can drop your comments, and then I answer them. Or if you're interested to look at the source code, you can go to the GitHub my account, tanhaohao/minisvelte. You can find the code, and yeah. So this is just for the YouTube channel. Basically, this is what I have a talk, but for YouTube, I'm gonna add more contents on this. I realized that I can build up more things over here to talk about more edge cases, more interesting stuff about Svelte Compiler, where we can build a more complete things. Over here, we can talk about some of the optimization that we have done. How about SSR, right? I probably will make a few more videos following up this to explore different things that we have done in a more of like a compile Svelte manner, but in your head manner. But this is like actually compile Svelte in your code, man. In the code, not in the head. So if you like this video, give me a huge thumbs up. If you find it useful, helpful, and you want to write something immediately, share my video as well as share the code that you've write, and so that everyone can learn from each other, right? So see you in the next video. Bye bye.